Okay, just a very quick reminder if you haven't seen this. I believe the exam schedule is posted for the course. Our exam happens to be very early. It's April 7th. I believe it's a Sunday. Okay? And our last class is actually the Wednesday of that week. So that means you only got about 3 or 4 days. I would suggest the following. So I might schedule some review session for the class to answer your questions. But before that, you may want to start preparing for the exam as early as you can. Otherwise, you just cannot cram all the information in just 3 days. It's not going to work. Okay? I will talk a little bit more about this. All right, let's start. Today, I want to mainly talk about just one single topic, which is very important for OOP. It's something called aliasing. Okay? So this topic is also discussed thoroughly for next week's tutorial videos, which I just uploaded. I'll send you lab 6, the last lab. I'll send it to you either later tonight or early tomorrow. So you can definitely have enough time to study. Okay, let's talk about object aliasing. It's the first time you see that, it might be a very weird phenomenon, but once we explain that, it's actually quite sensible. Okay? The only thing that you learned so far that's relevant, okay? Let's remind ourselves very quickly. Okay, let me just start a new page over here. Okay, let me just remind you very quickly. Okay, let's compare two declarations of variables very quickly. Let's say we have declaration number 1. If I say integer I, okay? Versus if I say points. Remember in your tutorial video for this week, we did a 2-dimensional point, right? Let's assume we do have a class called points, and then let's say P. Okay, so we're assuming that you simply got some existing class called points, where you define attributes and method, etc. That's what we assume. So now I want you to know very clearly about what's the difference between these two declarations over here. Both of them are variable declarations, both of them. However, there's a fundamental difference between them. Okay, let's talk about the first one and then followed by the second one. For the first one here, we talked about it already in the elementary programming. Basically, it simply stores value. For example, if it's an integer variable, it simply say I can be storing, for example, 3. But for example, if you say 23, it will not be compiling, right? That's something we learned in the previous elementary programming lecture. Now, whenever you try to declare a variable over here, let's say P is the name of the variable. And the point over here, okay, that's a very important hint for you. Every time in Java, I would say almost 99% of the time, if you see any type that is capitalized, you can see the P over here is capital, right? So this is referring to some existing class name. Whenever you have that, for example, the point over here is simply the name of the class you just defined. Whenever you have this kind of declaration, it's a different type. Okay, let me explain to you. In the previous case, if you got integer, boolean, also you got a character, you have double, you have float. So basically these types over here, all lower cases. You can see all lower cases for the name over here. So these are so-called primitive type. Primitive types. Primitive in the sense that it's very simple values. There's no structure for the value. Just integer I can be just 3, and also boolean can just be false or true, right? So that's something we learned before. Okay, primitive type. Now, in the second case over here, whenever you have the type name being referring to an existing class, we also see other example before, if you can recall. String is actually also referring to some existing class, which is capitalized. Also, scanner. Okay, so these two are something you have seen before we talk about OOP. So these are so-called reference type. Reference type. So now the reference here is basically talk about, informally, we talk about address. Okay, as I tried to explain last time, whenever you try to create a new object, the variable does not store the entire objects, because in general, the object structure can be arbitrarily complicated. And as you will see in this week's tutorial, the object itself might refer to other objects. Okay, that's something you will see for this week's tutorial. So in general, you don't store the entire object into the object variable. So what do you store? You store indirectly the reference or the address of the objects. For example, over here, the P over here is going to store just the value of the address. Okay, I want you to keep this in mind. So I'm going to go over this together in very much detail. Okay, so now for primitive type like I, you only store the value for the primitive type, integer, boolean, etc. For reference type, you only store address. By looking at the address, you can look up somewhere in the memory and do something from there. It's indirect. You always have to follow links by using the dot notation. Okay, for example, you might say p dot, for example, get distance, right? That's something you did in this week's tutorial. Okay. In the next week's tutorial, we'll see that in general, because every object variable is storing some reference, you can look up the address for as many times as you like. So you might end up having p.q.r. something. Okay, that's something you will see in the tutorial video. Okay, it's a very quick distinction between the two. Let's now do some exercise all together to clarify the matter. We do have some challenging one which we'll do all together today. Okay, let's have a look at this fragment of code very quickly over here. Let me just go over maybe on the iPad. I think that'll be easier. Okay, let's start with something simple. Okay, so now let's have a look at, I'm going to highlight line by line. If I say integer I is assigned to 3, so what do we have? In this case, we're declaring a variable I with value 3. Easy. The next line, this is important. What does it really mean when we say integer I is assigned to, integer j is initialized to be I? That's really important thing to remember. Okay? Basically, we are copying the value of I into j. So that means we're declaring a variable called j, and then copy whatever that is stored in I into j. So we got 3. Okay? That's, I want you to really understand the pattern over here, because the way we do the copy for reference variable would just be the same. Okay, but what's being copied is different. Okay, so now number 3. So now after this, if you say I is equals j over here, so that should be true, right? So that's easy to see. Line number 3, we try to say k is assigned to 3. In that case, we are really declaring just another variable over here, k, and then put 3 inside. You can also do some comparison over here, right? It turns out all the values are just the same, also true. Okay? Why am I doing this? I really want to show you something very similar in the next page, but I'm going to change the type of the variable from primitive type to reference type. Okay? That's going to be the tricky thing. Let's have a look at that. So now let's make the following assumption, something you are familiar with. Let's say we have a point class. Okay, we got the 2 attributes x and y, and also we got this simple constructor which will initialize x and y. Let's say. Let's now go over line by line. Okay, and then I'll trace it together with you. Okay, so now let's go for line number 1 over here. Line number 1 will say point p1 is assigned to a new object of type points with 2 and 3. Okay, as we said before, let me just give you a little bit review quickly. Whenever you see the new keyword over here, that means you're creating a new objects, right? Let me put a new objects over here. So you're creating a new object over here. Okay, so now I would say the type of the object we call point. By the way, it's really important for you to know how to draw a diagram like this, because as you will see, we're going to get to a very complicated program involving many classes. In that case, drawing is the best way for you to keep track. Okay? Try to really get used to it. So now we're creating the point class, and then we're going to initialize x to be 2, y to be 3. Okay? I'm going to omit the details for that part. So x will be assigned to 2, and y will be assigned to 3. Okay? So now let's give you a little bit more details. Think about what's really happening over here. Because it's a new object, so that means every new object has its unique starting address. Let me make it up. I will say 06123. Okay, just make it up. And let's say we are trying to assign this particular new object into a new variable p1 of type points. As we said before, p1 is going to store address for the point objects only. So now in this case, what do we have? Basically, you're going to have p1. Let me put it here. Let me just move this a little bit to the right, like that. So now we have P1 over here. So now what should be stored in P1? Not the entire object. No, it's not the case. We only store this particular address over here. That's being done. So we got 0, 6, 1, 2, and 3. So how do we draw this conceptually? You can draw it like this. That means P1 is really pointing to this particular object at the runtime. Okay? However, P1 might be overwritten for the address that's being stored. That means we might change the direction for the arrow. We might change it. Okay? That's exactly what's going to happen. So now, having this in mind, can we have a look at this line here? Line number 2. What's really line number 2 doing? That's something new to you. You haven't seen this before in the class. In line number 2, we are declaring P2 to be of type points, which means P2 is also going to store the address of some point objects. But what address should we store there? And in this case, on the right-hand side of the assignment, we'll simply say P1. Whatever that is stored in P1, we're going to copy that over to P2, right? That's conceptually the case. So let's try to do that quickly. What does that mean? That means I'm going to declare a variable called P2 over here. And then when I say I'm going to assign P1 to P2, that means whatever address that is stored in P1, I'm going to copy that over to P2, which will be 0, 6, 1, 2, and 3. So now, how do we draw the arrow? You can think about when I say over here. Okay, when I say this, so that means P2 is now going to point to wherever P1 is pointing to. Are we okay with line 2 over here? It's a very important line to understand. Okay? Let me just repeat very quickly. Okay? Whenever you're trying to do the assignments over here, where the left-hand side and the right-hand side, they are reference variables. In that case, you're just copying the address around from the right-hand side to the left-hand side. And the way you trace it is by drawing arrows like this. So that means in this case, P2 is just going to point to the same objects that's being pointed to by P1. Okay? So now, here's an important thing to really see. After this, what's going to happen if we try to do this particular comparison? We say P1 equals P2. Okay? What are we comparing over here? When you say P1 equals P2, you're just going to compare what's the stored values in P1 and P2. In this case, you're basically comparing this address over here with this address over here. They're the same address because it was copied over. So this will just be true. That's one way to look at it. Another way to look at it, which is more intuitive, you can think about whenever we have P1 equals P2, we're asking the following questions. Are P1 and, let me make sure you can see that, are P1 and P2 pointing to the same objects? Pointing to the same objects. Yes or no? Basically. In this case, let's see. You can see that, let me show you some highlighter here. When you say P1, P1 is pointing to this particular object over here, whereas P2 is also pointing to the same objects, so that's why it should be true. There might be cases where it is false. Okay? Okay, so that's the first one. Let's do another one. The next line over here, let's see. Okay, let's say this line here. So now, if I say point P3 is assigned to new points 2, 3. Now, in this case, we're really creating another new object, right? There's no reassignments for the object variables, just initialize a new objects. Let's draw that very quickly. So now, I'm not going to give you the details about address anymore. Conceptually, you just basically change the arrows around. That's all you're going to do. Okay, for this one, how should we draw it? You're going to create a new object over here, which is going to be 2 and 3. So I will just create this new object over here. It's going to be of type points with x and y. And also happens to be 2 and 3, just the same. And then P3 is going to store the address for this new object. So conceptually, you can draw like this. P3 is pointing to this object over here. Okay? Just about the arrows. That's why drawing is really useful. So now we want to see this particular line. Let's try this. It's a disjunction over here. Okay? So now P3 equals P1. Should that be true or false in this case? Well, if you know how to draw the diagram, all you have to see is whether P3 and P1, they refer to the same objects. P3 over here is referring to this object over here. And P1 is referring to this object over here. They are not the same objects. Okay? So P3 equals P1 should be false on the left-hand side. Okay? What about the right-hand side? The right-hand side is doing the following. P3 equals P2. Again, we did a similar exercise. P3 is referring to this object over here, right? The green one. Whereas P2 over here is referring to this object over here. They are not the same, right? Not the same object. So that should be false as well. So you got false or false. Eventually, you're going to get false from this particular assignment, Boolean expression. Okay. Now let's do one more. Okay. What if we do line number 5 over here? What if we try to say P3.x? What's P3.x? Whenever you see dot, okay, whenever you see dot in OOP, you will say something dot something else. Basically, you're going to look up the objects being referred to. Okay, that's really what dot really means. Okay, in a more general scenario, you might have as many dots if necessary. Okay, as necessary. Let's see this one, easy one first. I want to just go for this first one over here. What about this? If I say P3.x, this one here, how do we figure it out? What should be the value for P3.x? This is how you can think of it if you got a diagram in your hands. So now P3, first of all, find out the variable. P3 is over here. Okay? P3 stores the address of some object, but which one? So whenever you see dot over here, P3 dot, the dot over here is really about go for this particular address and follow that address to the memory location and locate that memory objects. Okay? So now in this case, what we will get is something like this. So you see P3 over here, P3.x is going to go to this particular object over here and find out what the x is. In this case, it's going to be 2. Okay? So now it will be 2 over here, so P3.x will be 2. What about P1.x? P1.x will do a similar exercise very quickly. P1 is over here, and you're going to go to locate this particular object over here, .x will be 2. So P1.x will also be 2. Okay, so P1.x equals P2.x, 2 equals 2, will give you true. Okay, so what are we doing here? I really want you to compare something over here. Okay, let me just add a new page over here. So if you got, let's say, point P1, okay, and also you have point P2. Let's say you declare the 2 points, and then you might do something to manipulate, create a new object, or do some reassignments. So now, whenever I ask you about P1 equals P2, the question is whether P1 and P2, do they point to the same objects? Okay, so whenever you see equals, that's really comparing the addresses. Okay, that's number 1. Number 2, you may want to compare maybe the contents of the object instead. How can you do it? If you want to compare the contents, for the purpose of this course, we simply do something very intuitive for you. We know that each point is characterized by the x and y. So what we can say is P1.x, okay, equals P2.x, and also P1.y equals P2.y. Okay, that's how we do it. Basically, we're doing a conjunction over here. We want to make sure all the attributes between the two objects are the same. You can see the conjunction over here. First of all, you want to make sure the x values are the same. And also, secondly, the y values are the same. And notice that the context object here is different. One is P1, the other one is P2. Right? We'll talk about context object and also how you can inquire about the attributes. Any question about so far? So far, it's still simple. If you want to compare one object with another object together, it's a little bit more advanced. But this way here, we simply say, if you want to compare, let's say, the contents for P1 and P2, we simply say just numerate the attributes you want to compare about. That'll be easier for this course. Later on, once you go to 2030, if that's one of the courses you want to take, you have to redefine some method. But let's not bother with that. Okay? I'll just make it a little simple for you. Again, there are two kinds of comparison for the objects. Number one, you use equal to compare the addresses. Number two, you simply numerate the objects out, numerate the attributes over here, use a dot notation to compare their contents, right? Either way. Okay, let's do something more challenging. Okay, so now we have warm up. Again, before I show you the final version that involves aliasing, I would like to just do one very quick exercise together with you. It's going to involve array and also some loops. Okay, that's also some nice review of the stuff. Okay. Basically, eventually, we want to know what exactly will be the outputs for 10 and also 11, eventually. But now, how do we trace the program over here? That's the question. How do we trace it? Let's see. Let's now do line number 1, 2, and 3. 1, 2, and 3. By the way, so far there's no aliasing, no reference type just yet. We're only dealing with primitive type. So line number 1, we're going to declare I1 to be of value 1. Line number 2, I2 will be of value 2. And for line number 3, I3 will be of value 3. Okay, very easy. So now, we want to see what's going to be the effects for line number 4. Okay? Line number 4, we're basically trying to, using the ArrayInitializer notation over here, and then we're saying index 0 is going to be the value for I1, index 1, and index 2, and etc. Right? Let's try that. Basically, what we have is we're going to create an array called numbers1. Okay, this one here, line number 4. Numbers1 is going to be of size 3. Okay, we got 0, 1, and 2. Okay, and then we're simply going to say I1, which is here, should be of value 1, copy over to the array. And also I2 should be over here, copy to position 1. And I3 should be the value over here, copy to position 2. Okay, that's what we're doing here. Line number 4 is also easy, not too bad. But it will be a little bit trickier if we get to creating objects as a reference type. Okay, let's try to do that later. So now let's say line number 5. What are we doing here? We're basically just creating another array whose size is simply the same as the size of numbers 1. Okay, so we are creating another array over here, numbers 2, which is going to point to another array over here. Okay, 0, 1, and 2. And what should be the initial value? That's also something I talk about in next week's tutorial video. Every time, if you do not initialize any value, depending on the type of the elements, is going to be of some default value. In the case of integer, it's going to be 0. In the case of double, 0.0. In the case of Boolean, false. Okay? What about in case of the reference type? We have a new keyword for you to learn called null. N-U-L-L, but we'll get there in the next slides, in the next example. Okay, so now we got numbers 2. Okay, initially everything is just going to be 0. Initially, 0, 0, and 0. So now let's try to look at the behavior for line number 6 to line number 8. We want to see exactly what's going on over here. Okay, so now let's try to look at that. The loop itself is actually quite elementary. We're basically having a loop counter initialized to be 0, and then we go all the way until the end. That's a very standard way of doing things. And then I++. Okay? What's going to happen in the first iteration? The first iteration is going to be like this. Let me just say ns for numbers. ns2 at position 0 when I is equal to 0 is assigned to ns at position 0. Oh, sorry. It's going to be assigned to ns1, right? Array number 1 at position 0. So what does that mean? That means over here, I'm going to copy the value of here and place it over here. So that means this is going to store 1 instead. Okay, that's what's going to happen for the first iteration. What about the second iteration? For the second iteration, I will be incremented from 0 to 1. So numbers 2 at position 1 is assigned to numbers 1, at position 1. That means for this particular slot, we're going to place it over there, the value at position 1 over here. So that means it's going to store 2 over here. Okay? Similarly, for the third iteration, it's going to replace the third value over here into here. So it's going to store 3 over here. Okay, very simple loop just to show you. Okay, so you get used to the formats we're going to do in the next slides. Now, here's the important thing. Okay, so now you can see that we basically got 6 different values. We got 1 here, we got 2 here, we got 3 here. We also got 1 here, 2 here, and 3 here. We got 6 different values. You can think about we got 6 different copies of the integers. Okay, so now here's the question. If I try to do line number 9 over here, I say go to numbers 1 at position 0 and change it to 4. Okay? So what I will do now is I'm going to go to position 0 for numbers 1. So numbers 1 is here. Go to position 0 and change it to 4. One thing to note, whenever you make a change to the elements over here, you only change the value itself. It does not affect any other elements elsewhere. Okay, that's one thing to keep in mind. However, in the case of aliasing, in the next for reference type, it's not exactly true. Okay, so now after this, what about line number 10? If you try to print out numbers 1 at position 0, it's going to be just 4. Okay, it's going to be 4 over here. What about you try to print out numbers 2 at position 0? It's going to be 1. Okay, it's going to be 1. So 4 and 1. Okay, that's a very quick review of array and loops. Before we go to something challenging, okay? Basically, we're going to extend this example over here by considering rather than integers, we're going to compare objects. Okay? That's going to be the challenging one. Okay? Let's look at that together. I would suggest the following. Okay? Can you just spend just 1 minute at least can see what lines of code we have, and then we'll trace them together. Eventually, what we expect you to answer will be line number 10, line number 11, 12, 15, 16, and 17. Eventually, we want to know what the values are. Have a quick look. Okay, so line number 1 should be here. Sorry. Let me just make it a little bit better for you. Okay, we got 17 lines of code over here. Just spend 1 minute to have a quick look. At least you know what the structure is. Somehow, the code structure is very similar to the previous one, but now we talk about person rather than just integer. Okay, give you another 30 seconds. I can tell you that the tricky thing about this example over here is you may want to draw to actually keep track of how the objects are being manipulated. It will be quite difficult to just calculate in your mind. It will be quite difficult, even for experienced programmers. So that's why we want to do it together. Okay, at least everybody is kind of familiar with the structure. I'll go line by line with you. Okay, so now we have the following assumption. Okay, let's assume that we do have a person class, which we went over in the previous lectures, and also for the person class, we have a mutator method called setAge, which will change the person's age. Let's say for each person we have the name, which can be Alan, Mark, or Tom, or Jim, and also each person also has an age. It's only 2 attributes. Let's assume that. Okay, make it simple. So now I would like to do things together with you. Let me try this. Okay, I do have 2 possible ways to present this. Let me just start a new page over here. Let's do line by line. Okay, let me go back to the slides over here. You will also see the example on the slides. Okay, that's something we just went over. Let's basically start line by line. If you're given a question like this, let's say later in the quiz or in the exam, how would you answer that? I would say start drawing right away. That would be the most effective way of doing it. So now, line number 1, 2, 3, and 4. For those of you who want to practice, maybe grab a piece of paper and try to see if you can draw any objects. And I'm going to draw them very quickly. Give me 20 seconds. I'm going to draw them on the iPad and I'll show you. Basically, you got 4 new objects over here. How do you draw them quickly? Okay, I'll draw them on my iPad. And don't forget, each person has name and age. Okay, give me another 20 seconds and then I'll be done with my drawing. Oops. Yeah, do take the opportunity over here to try to see if you can do it by yourself too. Mark, Tom, and also Jim. In the beginning, okay, we got Alan over here, and also we got Mark, also we have Tom, and also we have Jim. Okay, the 4 lines are here very easy. Okay, let me show you. So now we got 4 objects over here. Okay, so we got 4 objects, each one of them has a different name, right? You got Alan, you got Mark, you got Tom, you got Jim. If you say Alan.name is going to be Alan, Mark.name is going to be Mark, and etc. Okay, so these are the 4 objects we start with. Okay, let's try to go further. Okay, so this is interesting. Now, this is already challenging to visualize the first time. Okay, think it this way. We say persons1 is of type person array. And then we're trying to initialize the array with size 3. At position 1 is going to be store Alan. What does it really mean to store Alan, right? Position 1 is going to store Mark. Position 2 is going to store Tom. Let me help you a little bit over here. Okay, so now if I just go here, let me just give you another page over here. Let's try to discuss this. If I have something like this, let me use maybe a different color here. If I have person, which is an existing class, array, and then I say, let me just be consistent, I forgot the name. It's persons1, okay. Persons1 is initialized to be Alan, Mark, and Tom. Okay, that's what we have. So now how do we understand this line over here, which will appear a lot later? Okay, let's go piece by piece. First of all, we know that we're declaring a variable called persons1. And then we know that persons1 is going to be an array. Okay? But now, what's really new over here is what should be the type for each element in the array. Okay? We say that every slot in the array, every element of the array is going to store just the address of some person objects. Okay? Right, I'll write it down here. We're saying each element in the array stores the address of some person objects. For example, you can see we're trying to store the address Alan. We're trying to store the address that's stored in Mark. We're also trying to store the address that is stored in Tom. Okay? Okay, that's basically what it means. And now, what we really want to know is how to visualize this. But before I do that, let me just ask you one thing. Okay? Let's before I show you exactly what this is equivalent to, let's do a little bit quick review. Okay? If I say integer array, let's say is integers, is assigned to, let's say, 23, 46, and 39, for example. We know that it's going to create an array of size 3 and then assign the values correspondingly, right? You can think about, in this case, as we illustrated previously, it's as if we try to do the following. We say integer is, first of all, is of size 3. New integer, and then we got 1, 2, and 3. So 3 things. And then this number is going to go to position 0. Is at position 0 is assigned 23. Is at position 1 is assigned to 46. And also is at position 2 is assigned to 39, right? 23 over here, 46 over here, and 39 over here. Okay? That's how we understood. We apply the same reasoning to that. So now, how do we rewrite this particular expression here in a way that's going to help us? Let me show you. Basically, what we have is this. This can be rewritten to the following 4 lines. The following lines. First of all, we can declare the persons array. We can say person array persons1 is created to be a new array of type person. Of size, I got 1, 2, and 3. Initially, every element in the array is not going to store any valid address, just null initially. Okay? And then, how many assignments should we do in this case? 3. Right? We got 3 elements. So let me write it down. It's going to be persons1 at position 0 is going to be assigned to Alan. And persons1 at position 1 is going to be assigned to Mark. And then persons1 at position 2 is assigned to Tom. So now these are the 3 critical lines. Okay? So now let's talk about just one of them. If you look at this particular line over here, let's say this one. When I say persons1 at position 0 is assigned to Alan, what does that really mean? Again, what is really stored inside Alan? We know that inside Alan it stores some address, which means we want to store this particular address to position 0 of persons1 array. How do we change the diagram? So that means after, okay, let's say this one. This is how you can think of it, okay? So after executing this line, there are 2 things you should want to keep in mind. After executing this line, okay, number 1, persons1 at position 0 and Alan, they store the same address. Store the same address. Okay, because we just copy address from Alan into position 0 of persons1. Now, what will be the consequence of item 1? The consequence would be, since they store the same address, they point to the same objects indirectly, right? Number 2, persons1 at position 0 and Alan point to the same objects. Sorry about the running out of space. The same objects. Okay, I'm going to show it to you. So 2 points over here. Okay. So now let's see exactly how this can be visualized back to our diagram over here. Okay. Let me go back here. Okay. Again, I'm going to create a new array over here. I have persons1 array over here is going to be of size 3. Right? As I said before, it's going to be created of size 3 over here. Okay, index 0, index 1, and index 2. Okay, you know what? It's better to put maybe persons1 at the top because we also got persons2. Let me make sure. Okay, you can still see it. Good. Index 0, index 1, index 2. Think about the first one. When I say persons1 at position 0 is assigned to Alan, what does that really mean? Okay, that means whatever address that is stored in Alan is going to be copied over to position 0 of persons1. How do we update the arrow? That means over here it's going to point to the same objects over here. It's a very important step to actually follow. Let's do some very quick check. If you do it on Eclipse, you can do the following Boolean expression. After this particular assignment, if you say persons1 at position 0 equals Alan after this, it's going to be true, because now they refer to the same objects. You will see lots of stuff like this in the case of the tutorial video. Okay? By the way, just for more information, I want to show you something which I did yesterday on the tutorial video. This is some diagram you want to get comfortable with. Let me show you where it is. It should be a tutorial here. You will see a diagram like this later. That's kind of the complication we will expect from you when you graduate from this course. Basically, this kind of object structure over here involves 3 different classes. We got faculty, we got course record, we also got students. We got 3 different classes. Each one of them has some certain attribute that has a relationship with another one. But of course, you have to, that's why I created a tutorial for you. I'm going to walk you over to see how to do things from scratch. It's a very important knowledge to acquire if you want to learn about OOP. Okay? Just want to know what we are learning over here in the lecture. I want to build some intuition for you. So when you go over the tutorial, you wouldn't get lost. Okay, let's go back here. Now it's much simpler. So now that means over here, when we do this particular assignments, we're just going to change the arrow around. Okay? Make sure you understand that. Okay, let's do the rest. And after that, we're also going to say persons 1 is assigned to Mark. Okay, in that case, we're going to say this particular arrow is now, position 1 is going to now point to wherever Mark is pointing to. Okay, finally, we also get persons 2 is assigned to Tom. In that case, now this is going to point to Tom. So this is the diagram you should really have, at least in your mind or under your paper, after line number 5. Okay? That's a very important step to actually understand. Okay, let's go to the next line. Which one? You mean line number 5? Or? So line number 5 over here, if you remember previously, so basically, let me show you here. You're talking about line number 5 here? Okay, basically there are 2 ways for you to initialize the array, right? You can either say the array is simply assigned to some numeration of all the value. That's one way. It's called the ArrayInitializer. Okay. Another way to do it is simply create the array of corresponding size and assign each one of them. You can do either way. I'm just trying to help you understand this particular notation using the other one. They're equivalent to each other. Oh, sorry. Okay. Basically, you're talking about line number 5 over here. Okay. And then this is the so-called ArrayInitializer notation over here, right? You can either do it this way. You will simply say at position 0 is going to be Alan, position 1 is going to be Mark, and position 2 is going to be Tom, right? Another way to write it would be you just create an array of certain size and then assign each one of them, right? Yeah, basically we want to use some for loop to manipulate, which we'll see. Okay? Okay, so now let me go back to the diagram here. I do want to go over at least the loop today. We still have 5 minutes or 6 minutes. So now, what about this one over here? This one, we simply say person array, another one, persons 2. We simply say that's assigned to new person array, and then with the corresponding size, with nothing to be initialized, which means every slot in the array will be just null, the default values. Let's do that very quickly. So that means over here, I'm just going to have something like this. Can I just move this guy over here to here? Okay, you don't have to worry about it anymore. So what I will do now is I'm going to draw another array, which is persons 2. Persons 2 is also going to be of what size? If you look at the previous line, it's going to be of a size, the same size as persons 1, right? Of size 3, basically. Okay, let's do that. Of size 3. Index 0, index 1, index 2. Initially, if you haven't initialized every slot, it's just going to be storing null. Null is actually a keyword in Java, null, N-U-L-L. Simply because we know that every element in the array is going to store some address. Initially, there's no meaningful address to be stored yet. So we just say null. Okay? Let's go back here. And then, now let's play with this loop a little bit. We did see this pattern here in the previous page when there was no reference variable. Now, how is this one going to change the diagram? That's the question, right? So now, we want to go over the persons 1 array, one by one, index 0, index 1, index 2, 3 iterations. And then we want to do the following assignment in line number 8. Okay? Let's split up into 3 different iterations. So now, if you look at that, basically it's this line over here, line number 8. Okay? Let's write it down very quickly. In I can be either 0 or 1 or 2. When I is equal to 0, we're going to have persons 2 at position 0 is assigned to persons 1 at position 0. Okay. Persons 1 at position 0. Agree? That's for the very first iteration. But how do we update the diagram accordingly? Let's have a look at it right away. So now let's go back here, the diagram here. I'm going to write it down here. If I say persons 2 at position 0 is assigned to persons 1 at position 0. Okay, that's the first iteration. How do we update the diagram over here? Think about what it's trying to say. It's an assignment. The right-hand side says go to the address that's being stored at index 0 in persons 1 array. Store that address into position 0 of persons 2 array, right? Let me just try to help you understand this. So now if you go there, what about persons 1 at position 0? Persons 1 is over here. At position 0 is storing the address over here. We want to store that into the persons 2 array at position 0. Okay, copy this address over here into here. After which, persons 2 at position 0 should point to the same objects that's being pointed to by persons 1 at position 0. Are we okay with that? So after this, you can do a very simple check. If you try to say persons 2 at position 0 equals persons 1 at position 0, it will just give you true because they refer to the same objects. Okay? And we'll do something similar. Okay, for the second iteration, third iteration will be something very similar. I'm going to draw that quickly. So that means after the second iteration, we're going to store the address from here to here. So now this is going to point to the same objects like this. Similarly, for the third iteration, we're going to copy the address over here into here. That means it's now going to point to this particular objects. Okay, so this is after the loop. So now here comes the interesting bit about aliasing. Okay, so now after line number 8, this is what we get. Now line number 9, that's really interesting. Aliasing simply means the same objects is being pointed to by multiple arrows in the diagram. For example, you can see that for this particular object over here, let's say this object here. This particular object for Alan is being pointed to by 3 arrows. You can see arrow over here, and also arrow over here, which means this particular object has 3 different names. Okay? Now, if you try to change the attribute value for this object, it doesn't matter which name you're trying to use. It doesn't matter. Once you change the objects, the attribute value will be just updated for each of the names. So what do I mean? Let's have a look. If I now try to go back here, if I say persons 1 at position 0 dot set age to be 70. So what does that mean? Okay. Now let me go back there and then write it down, and then we'll trace it. If I say persons 1 at position 0 dot set age to be 70. So this is again the dot notation you want to get used to. Okay. So now let's try to see how we can trace this particular expression over here. So now you can have a look at this. Persons 1 is referring to this particular array. And you want to go to position 0, which is exactly the position over here. And then when you say dot, that means you follow the arrow over here to the object that's being pointed to, which is this object over here. And for that particular object, I want to call set age. I want to set the age for this particular object to be 70. So what do I get? I will simply get 70, so change that to 70. Okay, so after this, so now let me ask you this. I'm trying to say persons 1 at position 0 dot set age to be 70. Let me try to ask you something right away. If I say Alan dot age, what should that be? Alan is basically over here, which is pointing to the same object over here because this has been updated. So Alan.age will be 70. So now notice one thing that's really important. Okay? You can see that when we try to set the age over here, the context object is over here, persons 1 at position 0. After the change, we are trying to ask about Alan's age. However, it's going to give us the updated value. Why? It's simply because before that, if you simply do some check over here, you will see persons 1 at position 0 equals Alan, it will simply just be true because it refers to the same objects. So when you try to say persons1 at position 0.set_h, it's as if you try to say Alan.setH. That's why it will be visible as well. Okay, I'll stop here and then we'll continue this on Wednesday.